In software, the dream is to ship new features pretty much instantly. But the reality, well, it's often a slow, kind of risky process. Today, we're going to architect a modern software delivery pipeline on Google Cloud. We're going to create a blueprint to make that dream a reality. Let's get into it. And this is the fundamental problem every single development team faces, right? Do you move fast and risk breaking things? Or do you move slow and risk falling behind? The good news is, you don't actually have to choose. This explainer is all about showing you how to build a pipeline that gives you both speed and safety. Okay, here's our game plan. We'll start with the whole concept of a modern delivery pipeline. Then we'll dive deep into the two key tools that make it all happen. Cloud Build, which we'll think of as our code factory, and Cloud Deploy, our logistics network. Then we'll see a rollout happen in real time. And finally, we'll put all the pieces together into one powerful blueprint. We're going to start on the factory floor, Google Cloud Build. Just think of this as our completely automated assembly line. It takes the raw code from a developer and just methodically forges it into a reliable, tested product that's all ready to be shipped. So what exactly is Cloud Build? Well, it's Google's fully managed continuous integration service. It basically automates the whole process of turning your source code into that final deployable package, what we call an artifact, which is usually something like a Docker container. And the key here, you don't have to manage any servers. It's just pure automation. This is where the quality control gets baked right into our factory line. See, Cloud Build doesn't just compile your code. First, it builds the container. Then, it automatically runs all of our tests to catch bugs super early. And finally, it scans for any known security vulnerabilities. A piece of code only gets to leave this factory if it passes every single one of those checks. Okay, so our factory has produced a quality-checked product. Awesome. Now we actually need to deliver it. And this is where our logistics network comes in, managed by our second key service, Google Cloud Deploy. You can think of Cloud Deploy as the brains of our whole delivery operation. It's a managed service built specifically for Kubernetes and Cloud Run that automates the entire release process. Its main job is to move our application from development all the way to production, but in a really controlled and predictable sequence. The most important word here is control. Cloud Deploy doesn't just, throw code over the wall and hope for the best. It orchestrates this progressive rollout from development to staging and then to production. It lets us set up these approval gates and, maybe most importantly, it gives us one-click rollbacks if anything goes sideways. That right there, that's our safety net. So, theory is great, but let's actually see how this works in practice. We're going to follow one single code change on its entire journey, from a developer's keyboard all the way out to production. Okay, so here's the happy path for our code. A developer commits to the main branch, bam, that kicks off Cloud Build. Once that artifact passes all its checks, Cloud Deploy automatically pushes it to the dev environment. From there, it gets promoted to staging for some deeper testing. And then finally, with a proper approval, it's promoted to production. Now, each of these environments has a really critical job. Dev is just for a quick sanity check by the developers themselves. Staging is basically a mirror of production. This is where QA and product teams do their serious testing, like user acceptance tests or load tests. And then there's production, the live service for our actual users, which is exactly why it requires that final manual approval. So you might be wondering, what actually stops a bad release from getting to users? Well, the answer is promotion gates. You can think of them as these critical checkpoints that a release absolutely has to clear before it can advance to the next, more sensitive environment. And we really use two main types of these gates. Between dev and staging, we can use an automated smoke test. That's just a script that checks the core functionality. If that fails, boom, the promotion is blocked automatically, no human needed. But for that final jump to production, we require a human sign-off. This makes sure that a person is accountable for that final decision to go live. Look, even with all these checks and balances, sometimes things still go wrong in production. It happens. And that's why your ultimate safety net is the rollback. Cloud Deploy lets you revert back to the previous stable version with a single click. Honestly, this capability is just non-negotiable for any modern delivery pipeline. All right, so we've seen the individual components. We've seen the factory and the logistics network. Now let's put it all together into a final blueprint that you can actually use to architect your own delivery pipelines on GCP. One of the first big architectural decisions you'll make is how to separate your environments. For maximum bulletproof isolation, you can use completely separate GCP projects. For more of a balance between isolation and cost, you might use separate GKE clusters. And for simple, logical separation, you can just use different namespaces within a single cluster. The right choice really just depends on your team's needs for security and, of course, budget. So here it is, the final blueprint. It's actually pretty simple. Cloud Build is your single, centralized factory. Cloud Deploy is your logistics manager defining the delivery route, and each stop on that route targets a separate, isolated environment. That's it. Factory, logistics, and destinations. That's the whole model. So there you have it. We've laid out the blueprint for shipping code faster and safer on Google Cloud. The pattern is clear, the tools are ready to go. By separating your factory from your logistics, you can finally solve that old tension between speed and stability. So really, the only question left is, what are you going to build first?